As you've already seen, math processes are used in every facet of the real estate industry, from measuring square footage to determining your own commission rates and splits. As you move forward in your career, you'll find yourself even more comfortable with these calculations, but they can seem a little daunting at first for those of us who don't have a strong math background. Because of this, we're going to take some time to walk you through the basic processes that go into some of the more complex real estate mathematics you'll use. As we go, one of the things to keep in mind is the order of operations and equations. To do this, it'll be helpful for you to remember the acronym PEMDAS. It stands for parentheses, exponents, multiplication, division, addition, and subtraction. As we move through, you'll see how the order of operations makes it more clear. Don't worry, when you're done, you'll be mathing right along. Here we go.
The lending process is a major part of any real estate transaction, and real estate rarely changes ownership without some money being loaned to the buyer. But before we start talking lending and math, we need to define some key terms. When we talk about the principal, we're talking about the original amount of money that was loaned. The actual cost of a loan will often far exceed this. That's because of the second core concept, that of interest. Interest is effectively a fee that a lender charges to the borrower to borrow the money. We'll take on how interest affects a loan a little later. So let's start by looking at some of the calculations a lender will make before they even decide to lend money to someone. The first is what is known as the loan-to-value ratio. What this ratio compares is the loan amount and the value or purchase price of the property the borrower is looking at buying. The formula for the loan-to-value ratio is loan amount divided by the value or purchase price equals the loan-to-value ratio. This ratio is used to determine how much of the purchase cost will be covered by the borrower and how much will be covered by loaned money. The lower the ratio, the more attractive the borrower will be to the lender. Buyer qualification ratios are a pair of ratios that evaluate a borrower based on their income and the debt they could end up taking on. The housing expense ratio compares the borrower's gross monthly income against housing expenses such as mortgage payments and homeowners insurance premiums. That formula is monthly housing expenses divided by gross monthly income and then multiplied by 100. This equals the housing expense ratio. The debt-to-income ratio compares gross monthly income against all the monthly debts owed by a borrower. This is found by taking the total monthly debts and dividing them by the gross monthly income and multiplying that by 100. This equals total debt-to-income ratio. Like with the loan-to-value ratio, a lender is looking for lower numbers when it comes to a buyer qualification ratios. This is because these ratios show how much the borrower's gross income is being eaten up by expenses and debt payments. Lenders are looking for borrowers who have more than enough income to handle mortgage payments. Related to this are the maximum housing expense and the maximum total debt. Most lenders will only approve a loan if the borrower's housing expenses take up less than 28% of their gross monthly income. So, the formula used to find a borrower's maximum housing expense limit is gross monthly income multiplied by 0.28 equals the maximum housing expense. At the same time, most lenders set the limit on total monthly debt at 36% of the borrower's gross monthly income. That maximum total debt threshold is determined this way. Gross monthly income multiplied by 0.36 equals maximum total debt. Another factor a lender may look at might be that of equity. Equity is the market value of a property after subtracting the remaining principal of any loan that uses the property as collateral. Equity is often used as a measure of a borrower's financial stability since it shows how much debt they are already shouldering. The equity in a property is found by taking the market value and subtracting the remaining value or loan amounts to give you the equity. With all that covered, let's return to the concept of interest. As I said earlier, this is a kind of fee charge to borrow money. When interest is applied, it's added to the total cost to repay the loan. Interest is applied to a loan in one of two ways. With simple interest, a fixed percentage of the original principal, the interest rate, is added to the loan on a periodic basis. In other words, every month, for example, an amount equal to 15% of the principal would be added as interest to the cost of the loan. Simple interest is found using this formula. Interest rate multiplied by the principal equals the interest amount. But mortgage loans aren't subject to simple interest. Instead, with mortgages, the interest is compounded. When interest is compounded, each time the interest rate is applied, it's applied to a new principal amount made up of the old principal plus the last amount of interest that was added on. Let's say we have a $25,000 loan with a 5% compounded interest rate. 5% of $25,000 is $1,250. So, $1,250 in interest is added to the loan. The next time interest is applied, that 5% rate is applied to a principal of $26,250. This means that this time, $1,312.50 in interest is added to the principal. The formula for finding the future value of something subject to compound interest is future value equals the principal multiplied by 1 plus the interest rate to the power of the number of times compounded. So the mathematical shorthand version looks like this. Here, we'll break it down. FV is the future value. PR stands for the principal. I is the interest rate. And N is the number of times the principal has been compounded. Number of times compounded refers to the number of times compound interest has been applied in a period of time, usually a year. Now, don't be scared of that little n number hanging off the side of the 1 plus I. That's just an exponential. An exponential tells you that a value will be multiplied by itself a specific number of times. 5 to the 4th power is an easier way of writing 5 times 5 times 5 times 5. Now, back to what we were talking about. By adding an extra piece to the formula, we can find the amount of interest that will be added to our principal. Amount of interest equals future value minus the principal. So, amount of interest equals principal multiplied by 1 plus the interest rate to the power of the number of times compounded minus the principal. Or, all we've done here is added a step where we remove the principal amount from the future value. This formula shows the result of compound interest over a year. So what happens when the interest is compounded over several years? To solve this, we add a couple more pieces to our formula. Amount of interest equals the principal multiplied by 1 plus the interest rate divided by the number of times compounded to the power of number of times compounded multiplied by the number of years in the lifetime of the loan minus the principal. Or, for this shorthand, A is the amount of interest, PR multiplied by 1 plus I divided by N to the power of N multiplied by T is the future value. I is the annual interest rate, N is the number of times compounded, and T is the number of years in the lifetime of the loan. Now we can extend the scope of the loan beyond just a single year. The whole reason we looked at these compound interest formulas is because elements of these formulas are found in the formulas used to calculate mortgage payments. Before we get to calculating monthly mortgage payments, we need to define amortization. A standard mortgage is a fully amortized loan. This means that the loan is paid off by a number of equal installment payments. To find a mortgage payment, the principal of the loan is multiplied by a value called the amortization factor. To find the amortization factor, we use this formula. Amortization factor equals monthly interest rate multiplied by 1 plus the monthly interest rate to the power of the total number of payments divided by 1 plus the monthly interest rate to the power of the total number of payments minus 1. This is the most complicated part of this lesson. The shorthand version of this formula looks like this. AF is the amortization factor, I is the monthly interest, N is the number of monthly payments made over the life of the mortgage. Let's say we have a 30-year mortgage with a 6% interest rate. We'll be using this formula. But first, we need to find I and N. The 6% rate is an annual rate, not a monthly rate. So we divide the interest rate by 12, the number of months in a year. 0.06 divided by 12 equals the monthly interest rate, or I. So 0.005 is the monthly interest rate. We can assume that the interest is applied every month. For this reason, we'll multiply the term of the loan, 30 years, by the number of months in a year, 12, which will give us N. 30 years times 12 equals the number of monthly payments. Now let's return to that formula. With the numbers, it looks like this. We should start with both parentheses and add 1 to the monthly interest amount. Now we apply that exponential to the results. In effect, we're multiplying 1.005 by itself 360 times. The result is going to have a lot of decimals, so let's round off to 4 places, or 6.0226. Now we should get... Next, we'll focus on the left side of the division sign. We need to multiply the monthly interest rate by 6.0226, so we have... Then we'll move to the other side of the division sign and subtract 1 from 6.0226. We should get the following. And finally, let's divide 0.0301 by 5.0226. The result should look like this. To fully pay off the loan in 30 years, the borrower will need to pay 0.6% of the cost of the loan every month. However, 0.6% is a very small number. So when you calculate amortization factor, it's common to multiply the result by 1,000 to provide a whole number. Now the factor for this example will be 6. With that in place, we can finally talk about monthly mortgage payments. We already mentioned that a monthly mortgage payment is made up of the principal amount multiplied by the amortization factor. So the formula we'll use is the mortgage payment equals principal multiplied by the amortization factor, or the mortgage payment equals the principal multiplied by the monthly interest rate multiplied by 1 plus the monthly interest rate to the power of the total number of payments divided by 1 plus the monthly interest rate to the power of the total number of payments minus 1. In shorthand form, it looks like this. In this case, MP is the monthly mortgage payment, PR is the principal, I is the monthly interest, and N is the number of monthly payments made over the life of the mortgage. So the amortization factor is... See, nothing new or different. We're just applying our amortization factor formula to the principal. Let's say a property owner is paying back a $630,000 mortgage loan with a 40-year term and a 4% interest rate. We'll need to use the following formula to figure out the monthly payment amount. Mortgage payment equals principal times amortization factor. In this case, it looks like this. To simplify this, we should first figure out the monthly interest rate, I, and the number of payments, N. First, we divide the annual interest rate by 12. For this example, we're going to be rounding to 5 places, so we should have 0.00333. Second, we multiply the term of the loan by 12. And our result will be 480 equals N. Now, the formula looks like this. We should start determining the amortization factor. So let's calculate the values in the parentheses on both sides of the division sign, like this. Then we raise both 1.00333s to the 480th power. That gives us... Finishing out the calculations in the brackets, on the left, we multiply the interest rate by 4.93200. Then, on the right, we subtract 1 from 4.93200. So, after calculating the division, we should have 630,000 times 0.00418 equals the mortgage payment of $2,633.40. The amount being paid off by the monthly mortgage payments isn't just the principal. The total cost of the loan is made up of the principal and the total interest that will be added over the course of the loan. So, we can find the total cost by adding these two factors together. The total cost of a loan equals principal plus paid interest. It's more likely, though, that we'll know the monthly mortgage payment. In that case, we can multiply that by the total number of payments. We can use the total cost of the loan formula to calculate the amount of interest that was paid by the property owner. So let's say a property owner pays a total of $928,750 on a $440,000 loan. To find the amount of money that was paid in interest, we subtract the principal, $440,000, from both sides of the equation. So the property owner paid $488,750 in interest on the loan. Sometimes a lender will offer what are called discount points to the borrower. Discount points are a means of lowering the interest rate on a mortgage loan. Normally, a single discount point will lower the interest rate by 1/4. The borrower will buy a number of discount points, with each point commonly having a cost equal to 1% of the principal. The cost of a discount point is usually paid when the loan is issued. The formula for calculating the cost of discount points looks like this. The cost of discount points is equal to the loan amount times 0.01 multiplied by the number of points. The last thing we need to address is pity. PITI is the abbreviation for principal, interest, taxes, and insurance. A PITI payment covers not just the principal and interest, but also handles the homeowner's insurance premiums and property taxes. The purpose of a PITI payment is to ensure that the borrower is covering all the major expenses associated with a property. And the formula for the PITI payment is the monthly loan payment plus monthly property tax payment plus monthly homeowner's insurance premium equals the PITI payment. The formula can also be written like this. As you can see, while these calculations look complicated on the outset, once they've been broken down into their component parts and we understand the shorthand, the step-by-step process to their solution is much easier to understand.
Now you're mathing. There are a lot of formulas and equations used in everyday real estate work, from simple interest calculations to cap rates to gross rent multipliers, and the list goes on. As you saw, once a complex equation is broken down into its constituent parts, it becomes much easier to tackle and understand. And amortization is one of the tougher ones. But remember, most of the math you'll see is just about high school level, and in some cases, the math will have been done ahead of time. That being said, you should feel much more comfortable armed with the basics, like PEM does. Now, let's get to the next segment.